So they're still going on inverse, okay? But we're going to go to more complex problems. There's a whole lot of words, blah, 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 blah. Here's the original, find the inverse, match it up, and we'll be good to go. So I don't know about you, but I don't really like that it says y equals 0.5. You want to keep it? Great. I don't want to. So I'm going to go y equals 1/2 x because I feel safer in fraction world. I don't like decimals as much, okay? What value do you think I'm going to pick? X. Do you think I'm going to pick 1? No. I'm going to pick 2 because half of 2 is 1 plus 3 is 4. Okay? And then I go, okay, what number do you think I'm going to pick next? Good, 4. What's half of 4? 2 plus 3, 5. Anybody see patterns? You should. 6, 8, 6, 7. I can't help myself. What? Look at this. Plus 1, plus 1. Plus 2, plus 2. Hey, the pattern's 1/2, and it starts with 3. Great. All right, so what should be true then about my inverse? 3, 0, 4, 5, 6, 7, 2, 4, 6, 8. Okay. If I am doing the inverse, let's think about if I'm plugging in 0, what's the first thing I did? The first thing I did is I multiplied by 1/2. Then the second thing I did was I added 3. So if I'm going to do the inverse, I'm going to subtract 3, and then I'm going to divide by 1/2, which is the same thing as multiplying by 2. Okay, the inverses of each other. So then what does that mean I do? I take this number, subtract 3, and multiply it by 2. And some of you go, I don't think so. All right, let's try the 7. 7 minus 3 is 4, times 2 is 8. Let's try the 4. 4 minus 3 is 1, times 2 is 2. Aha. Now the line of symmetry of the two functions. That's what I went over last time, and that's the yellow. And if you look, what did I say it was? Y equals x. Y equals x. So when they say what's the line of symmetry of the two functions, they want to know when you fold it, where's the spot where technically if I went 1, 1, 2, 2, 3, 3, 4, 4, and I drew that line, and I folded my paper right on there, I should be able to see through it and perfectly graph the other line. Okay, so just in case, 3, 0, 4, 2, 5, 4. So look, if I folded this right on there, look at that. Boom, that goes on top of that. Boom, that goes on top of that. Okay? All right, I'll pick 0. Now, do you think I want to pick 1? Whoa, I'm already getting into big numbers, so I might pick -1. And I think I might pick -2. And then I actually already know the y value of this one. Does anybody know why I know it already? Yeah, because it's my vertex. Okay. So if that's the case, I'm probably going to pick -3 and -4 because it's squared, this matches this, and this matches this. 0 plus 2 is 4, times 3 is 12, 6, 6. -1 plus 2 is 1, times 3 is 3, -3. Okay, so let's check. 0, 6, -1, it matches up. So that means I should be able to go 6, 0, -3, -1, -6, -2, -3, -3, 6, -4. So if I'm doing the inverse, I lost my blue pen. Then that means I need to do the opposite thing I did when I plugged in the x. What's the first thing I did? I added 2. What's the next thing I do? I squared it. What's the next thing I did? I multiplied by 3. What's the last thing I did? I subtracted 6. So I'll put the inverse down here, okay? So that means if I'm going to go backwards, the first thing I need to do is add 6. The next thing I need to do is divide by 3. If this is squared, the next thing I need to do is square root, and the last thing I need to do is subtract 2. So f inverse of x equals, so let me put this in blue. Take my number, add 6, divide by 3, square root it, and then subtract 2. All right, let's check it. 6 plus 6 is 12, divided by 3 is 4. The square root of 4 is 2, minus 2 is 0. Cool. -3 plus 6 is 3. Divided by 3 is 1. The square root of 1 is 1. Minus 2 is -1. I know that I'm good to go. What's the line of symmetry every time? Y equals X. Ready? Let's graph it. Excuse me. 1, 1, 2, 2, 3, 3, 4, 4. So if I folded my paper and I had that see-through paper, I should be able to graph it. Looks like it's going to be over there. Let's see. 6, 0. -3, 1, 2, 3, -1, -6, -2, I'm having a hard time graphing right now, -3, -3, 6, -4, I think I'm off a little bit, but you get the idea. Look at that. So when I fold it, that ends up there and that ends up there. Okay, this one looks crazy. So for time, we would just, it would be really hard to find the inverse of this. We would just take this, and if we wanted to graph it, we just switch the X and the Y. All right, now let's go into more. All right, look at this. They give us this. We know it's quadratic, and they're actually asking us to simplify it. So they're saying, hey, I don't like it like that. Can you write it differently? So f of x distribute. And some of you go, I still don't like the way it looks. You could actually make it look like this too. Hopefully you see what the vertex is. The vertex is 0, 0, and there is a vertical compression. So if you vertically compress, it's going to be wider. Okay? All right. So let's do f of x. If I plug in 0, it's 0. I don't want to plug in 1 because I'll get a fraction. I'll plug in 2, 2 divided by 2. I'll plug in 4, 4 divided by 2. I'll plug in 6, 9. I'll plug in 8, 16. So I should get 0, 0, 1, 2, 4, 4, 9, 6, 16, 8. Okay, so if I was doing this problem, and I was taking the 0 and I was plugging it in, what would be the first thing you would do? Square it. Then you would divide by 4. So what's the first thing you should do? The first thing you should do is multiply by 4, and then you should square root it. So that means my inverse function should be 4 times x square rooted. Let's check. 4 times 1 is 4. The square root of 4 is 2. Yay. 4 times 4 is 16. The square root of 16 is 4. Yay. 4 times 9 is 36. Square root of 36 is 6. Yay. Okay. There's my inverse. If you're still copying these, I need you to pause the video because that means you're not trying to see the order of operations backwards yourself, okay? So if I was doing the domain and the range of this, I know that this is a quadratic, and that means it makes a U. So that means I know the domain of any quadratic is -infinity to +infinity, which is all real numbers. I know that the vertex is, let me see if I can get green here. I know that my vertex is 0, 0. So if you switch 0, 0, it's still 0, 0. Okay? So if I was going to graph this now, and I was to find the range of this, I know that it's at 0, 0. I'm going to fake it a little bit, okay? You're okay. Would be y is greater than or equal to 0. 0, +infinity. This should be review. Now, if that's the case, that means when I do the domain, look at this. The domain here should be this range here. The range here should be this domain here. So technically, I should be able to go, okay, this is -infinity to +infinity, and this is all real numbers. This is y is greater than 0, 0, +infinity. But there's a problem. And here's the problem. When I did the inverse of this, it's a what kind of function? It's a square root function. Well, do you remember when there's square root functions? It wasn't a u, it was a half u. Oh, so that means that's 0, 0. That means that's 1, 2. That means that's 4, 4. So let's look. The domain is right. But it wouldn't be y, sorry, that should be x because now it's the domain. X is greater than 0. Okay, that's good. The range, isn't -infinity to +infinity. Why are they saying that? Remember in the last chapter when I was telling you there's extraneous solutions sometimes? That's because you're assuming there's something on the bottom when you flip this, and there is not. So this is not going to be the range. The range is going to be y is greater than or equal to 0 because it's everything up. So there are restrictions in this case. So this is yes and this is no. Okay, which is what the extraneous solutions are. Okay. Oh, okay. So they want to know, is there anything when you put in the original that you can't put in the new? Okay. Well, we said those were okay. Well, what if I put -2 into this original? -2 divided by 2 is -1 squared is 1. So I should be able to go 1, -2, right? Well, if I plug 1 in, 4 times 1 is 4. The square root of 4, is that -2? No. So when we have the inverse, I'm noticing all the y values have to be what? Positive. Okay. All right. You can just do this on your own. Oh, yeah. So I want to show you something cool on Desmos. If you look, this was the problem we did on the previous page. And if you put x equals f of y, it graphs the inverse for you. And look at this. I even made a table so you can see how to do the problem. So let me go back here. And if I'm going to go back to this problem here, that I needed to do, which I think it was on this page. There isn't really, it doesn't do exactly what I want it to do. So in order to make sure that it makes the U that I want it to, sorry, sun's glaring in my eye, I need to make sure I put plus or minus. And when I put plus or minus, then I'll make sure that when I graph my U, that I get a U going this way, because this is the positive and that's the negative. And once I include the negative, now the range is -infinity to +infinity. Okay? So if you plug into, and I think I did on the next page, if you go x equals f of y, you can see the inverse just like that. Okay? So let me zoom in a little bit and let you see this. Okay, so we got a parabola. Does anybody know what the vertex is? Hopefully you can see that the vertex is 3, 0. Okay? If I was to fake this thing, which I did and then I whited it out, that would be 3, 0. And then I would go like this. I'm going to fake it right now, okay? We'll be okay. So that's g of x. So how the heck would I get g inverse? So if I'm doing g inverse, I have to figure out exactly what I did here. So in order to do this, the first thing I would do is subtract 3, and then I would square it. So then what does that mean I have to do? I have to go backwards. The first thing I would do is square root it, and then I would add 3. But remember on the previous page, if I did this, I just get, hold on, the vertex here, which would be 0, 3, here. And that would just give me the top half. How the heck am I going to get the bottom half? Well, I'd get the bottom half if I throw a plus or minus in there. Because remember, how do you get rid of a square? You square root it plus or minus. That way the domain and the range could be the same thing but switched. Now, some of you go, I don't know, Mr. Rifkin, this is pretty hokey. This does not look good. Okay, let me go over to the Desmos screen. Let me pause it and show you. So there's my original, and then there's my inverse. And then remember, it's always reflected over the line y equals x. If I didn't keep that and I went f of x equals, and then I did the square root, where are we? The square root of x plus, plus 3, I only cover the top half of that, don't I? But then once I take that away, then, I'm sorry, that has to be gone. You can see it covers the whole thing. Okay? Hopefully that made some sense. That was a lot of back and forth. All right, let's go over the homework real quick. I got 30 seconds. All right, do this, do the inverse. You can do this. Do this, do the inverse. You can do this. This is the ones where, remember, what we need to do is divide. I would put this one on the bottom. And when you divide exponents, you're really subtracting. Do the square root. We've done it before. This one, it's the same thing, inverse. This is a circle. Follow the directions. And then on this one, you have to find the equation of each one. So let me do one of them. Hold on.